At noon, Michelle started driving east from North Park Secondary School at a velocity of 60 kilometers per hour. At 2:30 p.m., Ms. Holtum, who was 500 kilometers north of North Park Secondary School, started driving south at a velocity of 75 kilometers per hour. At what time was the distance between them the shortest? So at 12 p.m., Ms. Chow was already driving north of. She started driving east from North Park, and at a velocity of 60 kilometers per hour. And I'm gonna name this as North Park Secondary School. And then Miss Holtum at 2:30 started driving south towards North Park, and she was originally the distance of 500 kilometers away from North Park. But while Miss Holtum started at 2:30, Miss Chow was already driving, so she already had covered the distance from North Park. So let's calculate that distance, because we want to find the least distance between them, right? And 500 kilometers per hour, and whatever time she was is like kind of when they both were on the road, so it'll only be appropriate to find that distance. So the distance Miss Chow was at 2:30 can be calculated by using the distance equals velocity times time formula. So the velocity for Miss Chow is 60 kilometers per hour, and the time that elapsed since 12 p.m. since she originally started driving is 2.5 hours. So Miss Chow had covered a distance of 150 kilometers away from North Park. So she started at 150 kilometers away from North Park. We are optimizing distance. We're trying to find at what time is the distance between them the shortest. So we'll have to find a relationship between distance and time. One relationship we know about distance is it can be equal to this. The Pythagorean theorem, the distance formula, which states that the distance is equal to the x component, x squared, as the y squared component, and then whole rooted. But this has two variables, and this doesn't even have time, so how will we find what time the distance between them was the shortest? Well, let's look at the x, which I'll label as this part, the distance Miss Chow is away from the school, in the east component, and then I'll label y, the distance Miss Holtum is away from the school, the y component. So what do we know about x? So we first, to know about x, right, we'll have to state a frame of reference time, and the frame of reference time that we had established earlier was when they both are on the road. So at time equals, at 2:30 p.m. we'll state time is equal to 0. Time is equal to 0. So that is our reference point for time. It is important we have a reference point for time because it's so hard to calculate time in this form. It's easier to calculate time when we have in the specific units like hours, seconds, or whatever. So the time I'm going to put in the unit hours. So when we have this, right, the x can be rewritten as x is equal to 150 kilometers, because she's starting at 150 kilometers at 2:30, plus the extra distance he travels over time. And the extra distance can be rewritten as the speed multiplied the time. We don't know the time. And then the y can be written as, so the Miss Holtum is 500 kilometers away from the school. As she travels, she gets closer to the school, so the distance between them decreases. So it can be written as 500 kilometers minus Miss Holtum's velocity, which is 75 kilometers per hour. I'm not going to write the units because it'll take too much space. Times the time. They will have the shortest distance, obviously, at the same time, right? Because it's at what time between them the distance was shortest. So what time on the road was the distance the shortest. So now that we have these two relationships, we can sub it into the distance formula, which will allow us to optimize for distance. So now that I have like a a simplified version of the distance formula, I can find the derivative. So then once I find the derivative, I can set it equal to 0 to find the critical points. And then finally find the points where the distance is between them is minimized, between Miss Howe and Miss Holtum. So the derivative of this is equal. That's just the timing hours. So time 3.089 hours from the reference point. The reference point is 2:30 p.m. So so we know that this is 3 hours. So at least above 5:30 p.m. To calculate the time in minutes, we have to multiply these two last digits by 60. So 0.09 times 60 equals to 5.4. So it's 5:35.4 minutes. So 5:35 p.m. is when at 5:35 p.m. is when the distance is the shortest between Miss Chow and Miss Holton.